Hey, what's up, guys? This is Chung here. So, today let's talk about take a look at another problem on LeetCode. Number 472, concatenated words. It's marked as hard. Yeah, I think. Yeah, I'm gonna give my own like here. Can I give both? No, sorry. Yeah. So you're given a list of words without duplicates. Please write a program that returns all concatenated words in a given list of words. So a concatenated word is defined as a string that is comprised entirely of at least two shorter words in a given array, right? Okay, so what does this mean? So for example here, cat, right? This is like you can treat this one as a word dictionary, and the cat is a one element, and then you need to find out the words that can concatenate with a shorter one, right? Not itself, right? So so in this case, only this, and this, right, can be treated as the valid answer here, right? And those cat, dog, rat can't you can't because there's no shorter string that can concatenate to this kind of words, right? So okay, so how do we how do we think about how do we hmm, get get the solution right quickly, right? If you guys remember, there was like a similar questions. I think that's a medium problem. It's called word break one. So in that in that problem, so you're given like a word. You're given a word, and then you're given a word dictionary. Word dictionary here, and you need to return. You need to write a program to check if this word, right, can be uh, can be breaked into any of this word dictionary, right? So basically, this problem can be break down into can you utilize the code from this word break one, right? And but I think one thing we need to take be careful here. There's a little bit difference from this like this word break one because for word break one, let's say you have a cat here, right? And this word dictionary, the word dictionary is also cat. Let's say there's only one element in this word dictionary. In this case, that program will return true because cat can also be represented by itself, right? But in our case, we need to return false, right? Because basically this input is going to be our uh, word dictionary, right? And from each from each of the from each of the basically we are going to get each of the word here, and then we're going to call this method, right, to check if this cat, right, if this word can be concatenated with this word dictionary except for itself, right? Except for itself. So I think there are like some ways we can do it, you know. We can one way of doing it is we can like every time when we pass the dictionary, right? Basically every time we choose pick a word here, we need to exclude that from this dictionary, right? We need to exclude that from the dictionary so that when we check when we check the the validity, right, for this word, we're not checking itself. Or or we can just add a if statement during when we check this like or we can use the same dictionaries, but when we return the values, we uh we check in the end if this like if the only word break we're getting is this word itself, and then we return false instead of true, right? So okay, let's start coding here, and hmm, let's see. I'm gonna define a DP since okay, so to calculate the word break one, I think we'll be using a DP, a dynamic programming uh, concept here, and then that's the result. So we're gonna have an answer, right? To hold the to store our result for this problem, and I'm gonna write the main structure here. So for word in words one in words, right? If DP if thing equal is true it's true, right? Then we just simply add answer dot append, right? Append word, right? And we just so the main the main for loop is very easy. It's just loop through each word, and for each word we check if it can be uh, concatenated between uh, by using any of those elements in the word dictionary except for itself, right? So so basically this is gonna be the word break one problem here. So word break one. You guys can take a look at this problem in on LeetCode, I think. Basically, we're using the same code except to check if this code if this the element if this no word can is not equal to itself, right? So okay, basically we're gonna have like a n, right? That's gonna be the length of s, and then we're gonna create a dp here, right? dp equals to what? So at the beginning, right, all the element is false, right? And then the length is gonna be n plus one. So so why we're doing the n plus one, I will explain it later. Uh, okay, and then we're looping through the string, right? I in range uh, I plus uh, n minus one. So n plus one, and then basically uh, this DPI. What does the DPI means, right? The DPI means so the DPI means at the length I. So this I means like the length of the string, right? At the length of the I, if this string from 0 to the length I, if this string can be like breaked into any of the words inside this word dictionary. If we can, then we'll return this I to be to set this I to be true, otherwise false, right? So here, okay, yeah. So we're gonna have a word set instead of a word list because set will give us a constant access time when we do a lookup, uh, comparing with the log n for a list, right? Basically, we're gonna convert this one to a words, right? So how do we check, right? How do we check if this I at the position I, if this string, if this word string can be break down into any of the sub words in the array, right? So what do? We loop. Basically, we do a loop for this j for each character in this I, right? Um, for I in range like for j, sorry, for j in range I, basically we try all the possible positions in the current string, right? If if the current position j is true, all right, and what? And and the substring is part of the word set. Then we know we can set this DPI to true, right? So starting from J to I, right? And then we can set this word DPI equals to true. Otherwise, we just simply keep it to be false. So how does this thing works, right? Let's just try uh, let's try the simple one, the cat, right? Cat, CAT, right? Okay, so we're gonna have the as you can see here. So we will be starting from 0 in this case, but in this case we're gonna starting from 1, right? From for I we're starting from 1. Basically, uh, we check the first character, right? Uh, let's say yeah, because when I equals to 1 and 2, right? We know C and CA they're not in any of those like uh they're not in the word dictionary, so they'll be false. So let's assume this is equals to 3 now, right? 3 means we are looking at this position. Now we have CAT, right? Okay, in word set, right? So basically the reason we will be starting from 0 is because basically for each of the current string, right, we'll be divide them one by one, right? So at the beginning, so we'll have zero strings on the left, right? So zero. So basically, this dpj is the left string, and this uh s, yeah, this s j to I will be the right side, because why we're doing the I, not I plus one, because the I is the length, right? And here, since in Python the right side is inclusive, sorry, it's exclusive, so it's I means I minus one here, right? This J means we will put zero strings on the left, and the rest on the right side, right? So in this case, the first one will be like 0 on the left and the cat on the right, right? And if this one is true, then we know, okay, so this string will be can be breaked, right, by using this word dictionary. If it can't, we do what? We move this j to here, right? Basically, in this case, j equals to 1 now, right? So now the left is C. So basically, we'll check if the DPC, right? If the DPC is true and the right side is in the word dictionary, then we set to true, right? Because every time, as long as we see a true here, basically we'll do a break here. Return DP n here, right? Because we already find a valid word break, so there's no need to continue. We can just simply break here, and then in the end we just return the dp n, right, which is the represents the whole string in the end, right? And okay, since as you can see here, we start from 0, right? And to make this one to be true, right? What does 0 means, right? So it means dp 0, right? When j equals to 0, it means there are like zero strings on the left side. So dp 0 is what we need for empty strings. We need to set that to true, right? Because empty string, we don't, if it's false, right? If it is false, basically this thing, uh any string that will have any strings we have left string on zero strings on the left side will be false because we're doing like an AND check here, right? So that's why we need to initialize this dp0 to be true, which represents the empty string. And basically that's the exactly the same implementation of the word break one. You're given a string, you use dp to set this thing, right? If this one's if the dpj is true and the rest is inside the word set, then the current one is true. And we just keep going until we reach the end of the word here. Then we just return the end one, the last one. And like I said, but the difference in this case is we cannot count the word itself when we do the comparison here, the check here. Basically, if none of them is true, only the word itself is in there. In this case, it's cat, right? So if the cat is in the cat, but in this case, we don't want this one to be true because that means there's no other elements that can concatenate to this current word except itself, right? We don't want that. So we can simply do and right and the right sub, right? If the and this like the rest string is not equals to the string itself. I think that yeah, that's the only thing we need to add here. Basically, if none of the previous check is true, then in the end, let's say we find oh finally we see a match here, but at this moment the the substring it's string itself, but we still don't want it to be true because we need at least two words. Okay, I think that's that's it. Okay, let's run it. Uh, yeah, okay, so if it's empty string, then yeah, so if this one is empty, right, and this will be like 0, yeah, this will be 0, and this, yeah, and here the first one will be true, but we will not go inside here, right? And the first one is true, which we don't need, I think. Yeah, I think we need to do a quick check here. If word is not empty, right, and the DP is true, then we can add it to the answer. Cool. Yeah, as you can see, this runtime is not the fastest one, the runtime. And but this one is like you can relate to the previous one more easily. If you know how to do the word break here, you can just utilize that to tweak it a bit. Like the way I did it was I checked this one here, right? Another way is that instead of comparing with the word set here, we can we can remove this like current as from this word set and then do the check here. Yeah, and I think another way of doing it is doing the recursion call, instead of the DP. Basically, the DP is like bottom up, right? Another way is to a recursion is from top down. So basically, we uh same same thing here, right? The only difference is here. So we still need to loop through each of the word here, but instead of build it in a for loop here, we can do a recursive call, right? Basically, every time we see a C, basically we just loop through each word. For example, we loop through each character here, and we see until we see the current character is is inside inside this word dictionary, right? And then we just pass the rest of the string to the recursion call. In the end, we return if this recursion call is true or false, right? And then we check if if this current one is true, if the current word has a string and the remaining recursion call also return true, and then we know, okay, that means, okay, we have current one, but the recursion call also give us some value. Then we know that these words can be concatenated by these two substrings, right? I I think I have that thing here. Let me see this one. Yeah, I think that was my uh, first implementation. So like I said, I think the logic here is not very straightforward, but the main idea here is basically I return the words count. I return the words count that this current as can get, and I do a DFS, and if this current word is in this word set, and then I pass this DFS, I I use this DFS and with the remaining strings, and then return the rest of the words count. I think I use a count here. Maybe I can use like a true or false, and then if this one is greater than 0, and then I append this word count, this one, and then I do a break, and then in the end I also use a memorization to speed up the performance, and in the end, so as long as the DFS give me anything that's greater than 1, right, then I know it's a valid answer. Yeah, for some reason this is faster. I think, hmm, yeah, I need to take a look why this one is much faster than the DP one. Cool. I think basically that's everything I can think of for this problem. Yeah. Thank you so much for watching the video. I'll be seeing you guys soon. Thank you. Bye bye.